Thank you very much, Raphael. Good morning, everybody. It's my great pleasure and indeed an honor to be here with you this morning. So the worst US engineering disaster in the 20th century was the collapse of the St. Francis Dam in Southern California on March the 12th in 1928. When the dam collapsed, a wall of water more than 10 stories high surged down the canyon, ultimately killing close to 500 people on its 54-mile journey to the Pacific Ocean. The St. Francis Dam was an engineering marvel built by respected engineers using the latest engineering techniques. It shouldn't have collapsed. But as the investigators worked to piece together what happened in the aftermath, it became clear that the engineers didn't fully understand all of the forces acting on the dam, forces that in retrospect made the collapse inevitable. Investigators discovered that the western side of the dam was built upon a conglomerate rock, which even when dry was of decidedly inferior strength and which, when wet, became so soft that most of it lost its rock characteristics. As water built up behind the dam and pressed into the ground around it, it was simply a matter of time before the west side of the dam collapsed as a precursor to the entire dam collapsing. If that wasn't enough, hydrostatic pressure pushing up on the dam as water seeped into the ground below the structure effectively reduced its weight and overall effectiveness. The impact of these hydraulic uplift forces was not fully understood and, in fact, remained hotly contested even decades after the dam's collapse. Essentially, the disaster was the result of a lack of understanding of the larger system or ecosystem in which the dam existed. It may have been an engineering marvel at the time, but once incorporated within its environment, the literal and figurative cracks began to appear. Now, in the evolving information age, as we make ever more critical decisions based on complex data sets gleaned from highly sensed, networked environments, understanding the ecosystems of those environments will increasingly mean the difference between success and failure, and potentially even life and death. So thank you for this opportunity this morning to address this gathering of leaders from academia, from industry, and indeed society. As I prepared for this speech, I asked myself, what knowledge can I possibly share with such an impressive collection of experts? So I decided to stick to what we know best at ADI, translating technological concepts and inventions into applications with real-world impact. You see, as academics and engineers, it's easy for us to prioritize invention, the brilliant conception and articulation of an idea, with less thought to its application, much less its adoption at very large scale. As the Austrian economist Joseph Schumpeter points out, however, innovation is the market introduction and diffusion of a technical or organizational novelty, not just its invention. The reality is that true innovation encompasses both invention and application. History is littered with the corpses of brilliant inventions that never found a viable, real-world application. So this morning, I would like to share some application lessons from analog devices that we've learned over the past 5+ decades of pioneering sensing, measuring, and interpreting technologies that connect the physical and the digital worlds. Our technology may lead the industry in high-performance signal processing, but it isn't just that we're smarter, more creative, or more inventive than others. We lead because we consistently and successfully apply our technology inventions to real-world problems to create innovations that help organizations make better decisions and deliver results with ever greater impact. So the challenge before us and this new center of excellence is really great. For millennia, humanity has struggled against intractable societal challenges such as poverty, illness, and environmental degradation. These are challenges that for the first time we may be able to solve thanks to the advent of ubiquitous and increasingly unobtrusive sensing. We now have an array of technology building blocks at our disposal that enable us to enhance and extend our collective nervous system to sense the world at unprecedented levels of detail and accuracy. Think about the possibilities as we begin to effectively leverage ubiquitous high-performance sensing to address the most challenging issues facing humanity today. The threat of global pandemics is eradicated as patient zero is identified in hours rather than weeks or even months. Sensing coupled with machine learning is able to identify and disrupt terrorism networks before they're able to commit their atrocities. Food and water insecurity due to famines and other natural disasters can be identified early enough to remedy the worst of their effects. The benefit of ubiquitous sensing is the insight and power it gives us to pull apart the threads of the veil blocking our understanding of these issues' catalysts and manifestations. Just as our understanding of the origins of the universe has advanced in parallel with advances in our ability to sense the cosmic microwave background radiation at ever greater levels of detail and accuracy, nanoscale ubiquitous sensing will reduce the gaps in our understanding of reality, making the world and our understanding of it less fuzzy by bringing it into sharper focus. This is the opportunity that nanoscale sensing places before us, but getting from here to there is not without its challenges. And these challenges are not just technical, but challenges of understanding and acting in awareness of and in concert with the complex, messy ecosystems in which we are operating. As everyone in this room appreciates, an ecosystem is incredibly complex due to the potential impact every element in the system can have on every other element. It doesn't take many nodes to be overwhelmed by the exponential growth of connections and the resulting complexity. In fact, as ecosystems grow in size and diversity, the exponential impact of interactions becomes difficult to accurately map, dissolving into a background noise that is difficult to tease apart. It's obviously exceedingly difficult to fully or even partially understand the complexity of the environments, the ecosystems in which we're operating. And if I'm being fully honest here, I'm underselling the complexity of what I'm asking, because the reality is we're not operating in just a single ecosystem, but in fact, multiple overlapping ecosystems. So let me give you an example of what I'm talking about here. One of the industries in which we operate is automotive, for which we provide products and solutions for myriad applications, such as advanced driver assistance and autonomous driving, infotainment, and powertrain management. As we bring a sensing product to market in this industry, we must be mindful of several key ecosystems in which we're operating. Our customer's larger system in which our product is embedded, the automotive manufacturer or OEM's vehicle in which our customer's system is embedded, and the consumer markets those OEMs serve. Our customers, the so-called Tier 1 suppliers to the OEMs, such as the Bosches, the Delphis, the Densos of the world, look to us to provide the highest performance components for their systems, but to do so with an eye toward ensuring the overall system is high performance. It does them and us no good if, for example, our automotive radar technology is cutting edge, but isn't optimized for our customers' needs and their systems functioning. And oh, by the way, they want that technology inexpensively and as quickly as possible with zero defects. As we work to satisfy our customers' needs, we're also mindful of the fact that their systems are being placed in automotive manufacturers' vehicles and that OEMs have their own needs related to those vehicles in terms of customer experience, weight, size, and reliability, and so on and so forth. And beyond that, we're mindful of the end customer ecosystem in which OEMs operate and the consumer trends that are driving their designs, modern features of assisted driving, connectivity, power and fuel efficiency, et cetera, et cetera. As our engineers are working to advance our technology, they have to be mindful of all of these ecosystems at the same time. To ignore any of them could render our innovations mere inventions that may never see the light of day. So the need to be mindful of the ecosystems in which we operate and their potential impact becomes even more important as we delve into the nano world and the interplay of smaller forces begin to have significant impact. At the nanoscale, interference from contaminants or elements like gases, particulates, humidity, ions, electromagnetism, bacteria, make the sensor designer's task considerably more complex. The corresponding benefit, however, is that nanosensing offers us the opportunity to map those various forces at a much more granular level, understand them, and begin to actually leverage them to our benefit. Ron Adner, professor at the Tuck School of Business at Dartmouth College, wrote a very insightful book, The Wide Lens, addressing the impact of ecosystems on businesses built on innovation. In the book, he describes how focusing on the two traditional pillars of business success, that is, carefully shaping your offering based on a deep understanding of your customers' needs, and then executing flawlessly and more effectively than your competition, are important, but not sufficient to guarantee success. Beyond traditional business execution excellence, he advocates looking to our right and to our left to expand the aperture of our vision and encompass the peripheral impact of our ecosystems on our success. And what's insightful about his approach to ecosystems is that he is not simply talking about aligning your partners and developing a strong supply chain, which rightly fall within the realm of traditional business execution. Instead, he is advocating approaching your business as being not just impacted by or even dependent on the ecosystem, but not existing apart from the ecosystem. From that perspective, you become aware of and deeply invested in the ecosystem's success. You begin to think through the issue of co-innovation, or the other innovations in your ecosystem that need to occur and be successfully diffused through the market in order for you to be successful. Right now, virtual reality is a hot technology, and the advances we are seeing in that space are truly inspiring. But think about how many different innovations need to occur for VR to be successful. Hardware problems that can handle the computing and the cooling challenges of 3D immersive environments. Connectivity standards that facilitate compression and transmission of tremendous quantities of data in real time. Software that can render 3D environments extremely accurately so that we aren't left with a sense of vertigo or motion sickness. If any of those areas do not innovate in parallel with the others, the VR market diffusion will slow, and perhaps those technology platforms will be passed over for something new that comes along. Beyond co-innovation, you need to think of the adoption chain and who else in our ecosystem needs to be harmonized to our invention. ADI needs the automotive tier 1 suppliers to adopt our technologies in order to have them deployed by the OEMs before you and I can use them in the cars that we drive every day. If any of those links in the chain chooses not to adopt, the entire chain, at least from our perspective, falls apart. If anything, this adoption chain is becoming even more important in a world of increasing returns driven by the power law, where the first mover or first system adopted has the potential to gain such gravity that it effectively freezes out other potentially better alternatives. Think of how difficult it would be today to create a search engine to compete with Google or an e-commerce platform to compete with Amazon, even if you had a better solution at hand. I'd like now to apply these principles to 3 different levels of ecosystems in which we operate at ADI, for which I believe you will find analogs in your world, no matter how you are innovating in nanosensing. So let's start at the component level, or to use a geographic metaphor, the local ecosystem. As you may be aware, the foundation of productivity and cost improvements in the semiconductor industry, Moore's Law, is under pressure, both economically and technologically. The economic costs of Moore's law in manufacturing semiconductors at ever smaller geometries are increasingly prohibitive, and at the smallest geometries, we are bumping up against the laws of physics. To continue to achieve the productivity and cost gains that we've enjoyed and relied on in the past, we must evolve our perspective and begin to think about the challenge in entirely new ways. We must move beyond the industry's historic single-dimensional focus on improvements in compute speed to a multi-dimensional focus that also encompasses new developments in processing architectures, systems on a chip, systems in package, and heterogeneous integration capabilities, advances that are sometimes referred to as more than Moore. In other words, at the component level, the ecosystem of the integrated circuit is playing a more critical role in enhancing chip performance than any individual part. At ADI, we often struggle with the complex trade-offs we must drive between component performance to optimize overall circuit and system performance. Bringing together the full ecosystem's capabilities from product to process to package in a coherent system optimized for specific use cases enables the system to exceed the power of the sum of its component parts. In addition, ADI has been investing significantly in what we term more than Moore manufacturing, wafer fabrication capabilities that allow us to combine all sorts of new and exotic materials with traditional processing to yield all sorts of new sensing devices. ADI has the silicon and manufacturing expertise, but we are looking to partners and research organizations like MIT to innovate new materials, devices, and structures to continue pushing ahead of what's possible today. So even at this lowest level component or local ecosystem, we increasingly need many partners to ensure success. Now let's take it up a level to the customer system, or to continue the metaphor, the regional ecosystem, where the data resulting from the sensing and measuring that takes place at the previous level is converted into usable, actionable information. This is where thoroughly understanding the breadth of our problem and how the ecosystem can solve it is critical. For example, there will be applications where an array of sensors will address the challenge we're trying to solve better than any single sensor. Since many system measurements, such as non-invasive blood pressure, require multiple types of measurement modalities to be combined, we're increasingly providing all-in-one solutions and using representations from multiple sensors to generate a reliable signal. It is also important to remember that sensing systems aren't just hardware. We need software, analytics, connectivity, and more to convert data into information and give the system the functionality necessary to deliver its full potential. All of these non-hardware elements have their own ecosystems and needs, and when you add that complexity, new issues emerge. Take, for example, the issue of system security that has come to the foreground in recent years. An ecosystem is only as strong or secure as its weakest link, and so it's not enough for the hardware to be secure or the software stack to be secure. The entire ecosystem needs to be trusted from end to end. Finally, once placed in a real-world setting, these sensor systems must be resilient. They need to have additional sensing functionality and embedded algorithms to evaluate the health of a system and enable the system to self-correct for any performance drift and sound an alarm to indicate when the system is outside its spec. In the future, sensing systems will even more closely model nature and human sensing that is vastly parallel, orthogonal, and highly adaptive to environmental conditions. I'm obviously describing a future that is beyond the capability of any one company or even groups of companies to achieve. Think of all the co-innovators and additional adopters this future actually requires. Finally, moving up another level of abstraction to the application, or if you will, the global ecosystem. I've saved the application ecosystem for last, but in many regards, this should be where we actually start. We need to begin by accurately describing the problem we are trying to solve or the application toward which we are applying our time, effort, and resources. We need to start the innovation process from the outside in by observing and understanding our environment and taking our cues from the challenges that we uncover. Then we can design an end-to-end architecture that takes the entire ecosystem into account and guides the development of our individual sensors and systems. Problems are more likely to emerge when we approach things from the other direction, creating brilliant solutions that are irrelevant to solving the problem at hand. This holistic approach to innovation also forces us to clarify our thinking about the market forces that might impact the adoption of our solution. This is a lesson that BlackBerry learned the hard way when it neglected demand for emerging touchscreen functionality, trusting instead in its market dominance and popular keyboard, which ironically had previously displaced the handheld market-leading Palm stylus and graffiti script. Most importantly, a holistic approach allows us to think through where we are unique and will have the greatest impact using our own resources and capabilities, and where we need to leverage partners to best solve the challenge that we are pursuing. Something we at ADI have learned through experience is how essential it is to pick your ecosystem's partners very, very wisely. You have to find partners that align to your application-specific values and goals to ensure the long-term stability that you need to be successful. As ADI has adopted this ecosystem mindset, the conversations we have with our customers have evolved and developed. We're no longer just selling our hardware, we are selling the capabilities of our ecosystem. I once heard that innovation today is like a bustling, living information market or bazaar where different vendors, offerings, and ideas jostle and collaborate in partnerships, both transient and long-lived, to address problems and challenges as they emerge. These dynamic partnerships increase the likelihood that a novel technology or application will arise and find success. Think about how successfully Apple brought digital music to market. They weren't first, and I don't think anyone will say that iTunes is a perfect platform, but what they did better than anyone else was understand the larger ecosystem and work with partners to create a sustainable industry that they still indeed lead today. In contrast, consider the plight of the Philips Electronics high-definition TV technology that was fully 20 years ahead of its competitors in the 1980s. Despite its brilliant technological breakthroughs, the Philips HD TV was a failure because it didn't consider the technology and market interconnections it needed to be successful. There were no cameras capable of creating high-definition content. There were no high-definition transmission standards, and so the Philips HD TV died before it had a chance to change the way we experienced TV. At ADI, we're aware that our future success will require us to increasingly partner and cooperate at an ecosystem level. It will require new ways of thinking about who we are and how we operate. That's why a few years ago, we established our analog garage here in Cambridge to experiment with looking to the left and to the right, more than we ever did in our previous 50 years. We understand that the world is embarking on a period of great technological innovation, sparked by an explosion of, yes, ubiquitous sensing, but also pervasive connectivity, advanced cloud and analytic capabilities, and, of course, artificial intelligence and machine learning. These are areas in which ADI and our partners together can best excel, each bringing something unique to the party. Analog Garage is a place where our ecosystems come together to grow their ideas. It's an incubator program in the true sense of the word, providing a path to propose, explore, and scale new technologies and new business models that no single entity in our ecosystem could accomplish alone. So I hope that I've effectively conveyed the backdrop against which our nanosensing initiatives and inventions take place, and with which they must wrestle and leverage to achieve their full potential. Together, those of us in this room, as inventors, but also members of a vast ecosystem, have the potential to solve problems that have plagued humanity for millennia. So let's commit to solving the problems that matter most. For example, let's take on the issue of food and water security. Let's continue the transformation of healthcare from reactive to predictive. Let's take on the issue of environmental degradation and create a world of sustainable energy. And let's address the possibility and challenge of smart automation and smart robotics. There has never been a more exciting time to work in our field, both in terms of academic research challenges and design challenges on the industrial side. The SENSE.nano Center of Excellence is perfectly placed to exploit these opportunities due to the ecosystem it is leveraging, combining MIT's sterling record of investment and achievement in science and technology, its connection to startup incubators, and its tight relationships with leading industry partners in the field, such as ourselves. So we at ADI look forward to continuing our long and fruitful partnership with MIT and wish the SENSE.nano Center of Excellence every success in future. Thank you very much.
All right, Vince, really, thank you very much for such an inspiring talk. We do have a couple of minutes if you're willing to take some questions.
Of course, of course.
Any questions from the audience? Yes, in the back.
I guess, what have you presented us with possibilities of the future, very exciting, and also the challenges we face. What examples have you seen that have been successful and why?
Do you mind repeating the question?
Yeah, so you're talking about examples of specifically nanotech or sensors in general?
Ideally both.
Yeah. I think in terms of the nano-specific questions, we have some of our technologists here in the audience who can handle those. I think from our perspective, you know, I'll give you an example of success that we've experienced at ADI. We are today a major supplier of clinical-grade vital signs monitoring technology for different health modalities. And there are many players. When we started in the market, we had a lead in hardware technology. There are many hardware providers today. How we keep our lead is by partnering with medical institutions, by partnering with great sensor companies. We have some of our own organic sensors. We also use sensors from other companies. We've partnerships with computational biology companies to help us read information from many, many signal sources. And today, we keep our lead in the business with a hardware platform, but the differentiation today is the application insight that we have, that we produce ourselves, but also with partnerships with companies like LifeQ, and indeed here working with MIT and the MEDRC here locally. So I think more and more, one of the things we've learned is that to be successful in sensing, you've got to take it an application at a time and build very much a system mentality and be prepared to look at yourself not as a cathedral, but as a bazaar. And clearly define where you have uniqueness, where you need to bring other unique capabilities. And of course, as an industrial company, we have access to the end customer in the markets. So we have technology uniqueness, market uniqueness. But more and more, as we connect nodes together, the complexity of the applications increases. Partnerships are becoming more and more critical for us. But I think it's taking very much the application and approach, and not just doing the sensing and the measuring, but doing the interpretation. That's where the value, I think, in the application is long term.
Thank you very much. I apologize for saying excellent.
Thank you. Thank you.
Other questions? Yes. All right.
Very good.
There's one more question right there.
So ADI works with hardware, right?
I beg your pardon?
ADI works a great deal with hardware.
Yes.
Hardware, right?
Yes.
how do you see the problem of interfacing hardware in the world with soft machines like humans? How do you go sensing in this environment?
Yeah, I think that's a terrific question. I think as a company, we have a hardware heritage. We've been developing more software capability inside ADI. In fact, the fastest growing part of our R&D budget is really in algorithmic and software development. I think in terms of interfacing with humans, it's really having a very, very deep level of insight into how the technology makes an impact on humans in healthcare, in cars, for example, and being able to translate that application insight into, if you like, the boundaries, the boundary conditions for defining products and delivering products that are both hardware, sensor, conversion, and as I said, more and more interpretation and software. But I think, as I said earlier, the real breakthrough for us as a company is not just innovating from the inside out, building the building blocks, looking for problems. We're looking for inspiration from the applications and working in to understand how to make greater application impact. In fact, that's a thrust. We have a three-pillar thrust inside ADI in terms of customer engagement, application insight, and pushing the boundaries of technology to ever higher levels. So I think that application insight is a huge differentiator for our company. And it's something that we've been adopting and building our culture around over the last 5 or 7 years.
All right.
Okay.
And yet, one more question.
How does ADI think about the need and the opportunity for the foundational and pre-competitive research that needs to happen to enable some of the things that are required not only for ADI products, but to fuel the innovations in the ecosystems?
Yeah, I think that's a great question, Brian. I don't know if everybody heard it, but how does ADI, if you like, describe the competitive advantage before we move down the track? I think it is largely about, there are certain things we know intuitively. We know the converter business, the data converter business very, very well. So we know what comes next. We know what the benchmarks are. I think in terms of increasing our competitive advantage, getting that deep application insight and being able to describe the problems we think we're trying to solve very accurately that resonate with us intuitively and empirically and scientifically. I think that's where we see more of the competitive advantage coming in the future. And we know, I think when you look at the trajectory we're on as a company, we'll keep pushing innovation from the inside out. We'll keep building better building blocks. But more and more, we're going to take our inspiration and insight from the application back in and create this marriage between the two pieces. So there's an inside out and an outside in approach to building competitive advantage for the company long term. Hopefully that answers your question.
Excellent. Yes, please.
There's one ecosystem that you didn't mention in your talk, and that's the government ecosystem. And can you make some comments perhaps on how that impacts your business?
Yeah, it's a very good question. So the question is, what effect does the government regulation have on the ecosystems? I think the areas where government, I think, is interested, perhaps baseline security will become a need that gets regulated over time. And of course, communication standards. The adoption of these systems is dependent on consistent communication standards. So I think there are the two areas. I'm on the board of the Semiconductor Industry Association, and we talked about where, as a group, we should get involved. But what we decided is that aside from security and connectivity communications, everything else is open to the interpretation of each company and how they build their own particular approach to solving problems. But I think they're the two areas that come to mind as most important from the government standpoint.
All right. At this point, if we can one more time thank Vince for indeed joining us this morning.
Thank you, Glenn. Thank you. Thank you. Thank you very much.
I just want to thank Vince and ADI also for being the founding member company of MIT.nano. Indeed, through your partnerships, we'll know how to focus our own efforts. I often like to say MIT can solve any problem. We just need guidance on what
solutions.
what we need to be working on. So thank you very much.
Thank you very much.
Appreciate it.